We talked about some object-oriented programming inheritance. Next thing I want to do is build a calculator class. We can start moving a little bit faster now that you kind of have the basic syntax and understanding here. So if I were to make a calculator class, like calculator, and I want this calculator class to just be able to do, very basic, calculator stuff like add, subtract, multiply, divide. Um, like, how would you guys recommend I construct the class?
That's a good
Curious,
question.
Yes.
Oh, I think I lost. We might have lost Justin. I shouldn't have flipped over because now you guys can see. It's I have that like
My
little problem
computer's
where I can't see her.
being really weird. It's like or my connection is. But I was saying I would create a class called calculator and then
Yep.
create some functions.
Am I sharing my screen right now? I want to make sure I am.
No,
No. Okay. Well, that's a problem.
Create some functions for multiply, add, divide, subtract.
Awesome. Yep, that's exactly what we would do. We'd do add, add, like let's just do A and B, return A plus B. We'll do the same thing here, def, stub, A, B, return A minus B. We'll do def, mult, A, B, return A times B. That's how you do it times. Def, mult, A, B. I think how you do a divide in Python. There might be a function for it. Let me just Google this real quick. Different languages. Oop, why is my keyboard is no longer working? Divide. Oh, it's simply division. Okay. B. Wait. So if I want to go down here, I can just do, calc equals calculator. You can do that, yeah. And then calc dot add a 1 and 2. Just do print. Print calc dot add 1, 2. Pull up my terminal here. My desktop, where the file is, Python 3, plus pi. And I've typed something in wrong. Calc is calc. Save. Run it again. And we have now another error. Calculator takes 2 propositional arguments that are given. So I forgot the self keyword. Just an old Pythonism.
why is that again?
There is an actual reason in Python for it. I can't remember it. I've looked it up before. It has something to do with like the class structure needing to recognize this function as a non-static function or something. It's like it gets into complicated reasons. Python's built on C++, and there's some stuff with like pointers and references and things that we haven't really covered yet with memory, because we would do that if we get to like C++. And so like inside of a class, in order for it to know that this is a method of the class, it needs to have the self keyword at the beginning. It's kind of odd. I could find you a real answer for that at some point. Apparently I have super bark up here because I'm still printing other
The use
stuff.
of it, though, is if you have a function that you want to call another function that's within the class, you would be able to use that using the self keyword there.
Yeah, I could be like def, fancy, self, A, B, like this, and then I can go self dot mult A, B plus self dot add A, B. And I can even do fancy stuff like this because I have a plus operator there for stuff I need to return statement. I can do like self dot add. Oop. And what this is doing, this fancy like thing, is it always like it's just like PEMDAS, but like a parentheses, like the lowest level thing gets evaluated first. So it will evaluate basically this expression self dot mult A plus B, then it'll evaluate this one self dot add A plus B. Then now the two arguments of self dot add are evaluated. So then it would like, add those two things together and you get a result. If we want to test it with 1 plus 2, fancy, we could do this. Click enter, now we get 3.5. Apparently that is what this comes out to. Trying to think why, but I won't even do the math right now because it's not important. Okay, so that's like how you kind of do stuff. You can build really fancy things. One other thing I'll talk about real quick is the mod operator. And I'm just going to name a function modulo just in case. Self that add a, and now I'll talk about the next example. I want to talk about a classic computer sciencey problem that comes across a lot. It's called FizzBuzz. And it's a classic interview problem. The objective of the interview problem is you have a list of numbers you're trying to print. And if it's divisible by, if it's divisible by 2, you want to print fizz. If it's divisible by 3, you want to print buzz. And if it's divisible by both 2 and 3, you want to print fizz buzz. Otherwise, you just print the number. And so the way that you handle this, I'll make this a fizz buzz function, is you're gonna need the loop. You're gonna have to do like a for loop in here. It mixes a bunch of good stuff together. So for loop would be like, or we'll do a while loop because it's easier. More like other syntax. So while I is less than, let's do 10, we're gonna loop to 10, and I'm gonna increment I every time. It's 1. So it'll stop, it'll go from 0 to 10. I think I might have to say I is equal to 0 at the start. Give it a definition to begin with. It's going to start at 0. It's going to loop, increment, and go to 10. So while that's happening, we will do the following. If I mod, it might be percent Python. Hopefully it is. Mod 2 is equal to 0, and I'll talk about what that is. Print is this. This percent sign is an operator that we have not talked about yet. So it is actually in computer science, it's a numerical operator. So we talked about numerical being plus, minus, add those types. Mod is one of those, meaning that it numerically evaluates something. Then there's comparative operators, which become true or false. So they become, they're like greater than, less than, equal to, those type of operators. And then there is logical operators of and, not, or. And we talked about those up top. They're still in notes if you guys want to go back and look at them. This one combines all 3 of those, which is why it's kind of a great problem. So, but the mod operator, what it does is it says return the remainder after division. So it wants you to divide 2 into I, and then whatever is left after the decimal point is it chops off the decimal point, just takes that as an integer. So if I is 2, for instance, it would return like the remainder after division. Actually, sorry, that's not what happens. It's like a fraction. So the remainder after division of 2 divided by 2 is 0, because there is no remainder after division. It's perfectly divided. If you do 1 mod 2, it should produce 1, and we can even verify that here. Make sure that I'm telling you correctly. So 1 mod 2. Let's see what we get here. I'm gonna pause the fancy function work. Is 1, right? Because it becomes 1 over 2. It removes the bottom of the fraction and just gives you the top. So if we do 2 mod 2, what happens? 0, because you get, if you think about it literally in terms of like second grade math, you now have a 1, a big 1, and then you have 0 over 2, and that 0 over 2 is what it's returning. Does that make sense?
Yeah, that makes sense.
Okay. It's very important in computer science, which is why we've created an operator for it. It's very useful, and FizzBuzz is one of those problems that if you don't know mod operator, if you're missing some basic fundamental computer science, you probably fail the problem. Coincidentally, I failed my first programming interview problem because I didn't know it before I really got into programming interview like over a decade ago. But it's pretty common. My wife actually had the same problem when she first started her job, but I taught her, so she knew what this was. Okay, so FizzBuzz. So that's our first one. The next one would be if I mod 3 is equal to 0, we are going to print buzz. And the last one, we actually need to do else if here so that it stops if the first one is true. There's going to be a mistake here, but it's okay. We need to reorder this. So this is going to be else. This is going to be elif, and then we're going to have an if here, because this is the conditional that we're going to print FizzBuzz for. FizzBuzz, and then and actually we need to do an elif here because I want to print the numbers at the end. So we're going to do a print. So if none of these are true, I want you to print I. If I would have just done if, there's a case in which like the first case could be true and the second case could be true. So you're going to get a lot of like duplicate stuff. But I want it to be exclusionary. So I only want it to run 1 within the full control flow statement. So this is what I got here. Does anyone know what the first condition would be to be FizzBuzz? Knowing that if both 2 and 3 are divisible by I, then we will get FizzBuzz. Does anyone know how to write that statement? I want to take a crack.
Would it be like an or?
Yeah, you're on the right track. It's actually an and, but you're on the right track. So
if it's divisible by 2 and 3, then it'd be FizzBuzz.
yes. So it looks like this. It looks like, if I is divisible by 2 and I is divisible by 3, then you get FizzBuzz. If you were to do an or here, no worries, because I might have explained it kind of weird, but like if you were to do an or here, like it would just run this anytime that either 2 or 3 is divisible by 3. But we only want to do FizzBuzz when both of them are divisible by those numbers. So it's kind of like factorization. So this should work. We are going to just run it FizzBuzz. Maybe I have a syntax error. We'll find out. Oh no, I don't. So now we have FizzBuzz, 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 etc. Which is good because 6 is divisible by both. 2 is a fizz, 3 is a buzz, etc. So we're in a pretty good spot there. A way to make things even more generic are to do something like length as a variable, and then say length here, and let the user of the function specify how long they want it to be. So I could be like, I want you to print out 20 numbers now. Boom, I've got 20 numbers here, and it tells me which ones are fizz and which ones are buzz. But these are the type of things that you can do with kind of the foundational computer science, and everything else just gets built on top of that stuff. So what I want to do next is I want to talk about the next layer. Again, this is like a crash course, so I'm not like trying to have you guys type everything and force it through. But we can always go back and do like more detailed examples if you guys want to actually be like the programmers yourselves. No problem. I want to talk about OO design patterns. This is like the next level. And so when I mentioned in the chat last time we chatted was that object-oriented programming, and in fact, I'm going to go to this OOP design patterns. There's a great website for this. I really like Refactor Guru, like probably my favorite. So there is we kind of stole, like you've noticed, we stole a lot of things from like physical 3D world, where it was like, we had some basic math and we kind of figured out how to reuse the math. And then when we got to object-oriented programming, it was like, if I want to describe a cup, I'm going to say like, what's the cylindrical size? What's the width of the property of the class? So I'm going to have those as like members. And then I'd probably have like a function that's like drink or like, deliver taste or something like that to try to describe how I would describe in words something about a cup or maybe a drink. Same with like animals, dogs, cows, trains, trucks, cars, rockets, etc. Well, we also learned that like it would be really good if we kind of standardize some of the ways in which we build things in computer science. And to be clear, this is kind of like advanced computer science, I would say. I had a lot of conversations really in early days of MSI with Kevin Dent. We were going back and forth about like, did we require people to know some basic object-oriented design patterns? The problem is sometimes you get really talented developers who haven't been exposed to this. So like, how much do we grade them on like their ability to build this type of stuff? So anyways, object-oriented design patterns are just stealing the ways in which we build physical buildings for the most part, or physical things, and applying them to computer science object-oriented. It's kind of goofy, but we really do. So let me show you a couple examples here, kind of what's going on. So it's broken into three categories. There's creational patterns, which are designed to create a thing. Think more generically than just an object. You're creating an object, but like you're generically creating a thing. Structural patterns are like, I need some way to categorize the structure of something, to capture the structure of something. And then behavioral patterns are, I need to handle something in some particular behavioral way. And so we'll talk about those. I want to start with creational because they're kind of the most standard. I would love to get this kind of off my screen, but I want to be able to see you guys too. So I'm going to move it over here. Okay, so creational design patterns. Factory is the most common. And actually, when I ask people this in interviews, if I ever do, usually they know this one. Factory is literally like a manufacturing factory, just like, Henry Ford back in the day, developing Ford in the manufacturing line. That's literally what we try to create when we create a factory pattern. So it's essentially a class that allows you to create objects from that class. So if I were to try to make a car in computer science, I would probably make a class that has the ability to generate or create wheels, a frame, an engine, steering wheel, a color, and that type of stuff. And then after I've created the objects from the class, I would then assemble them outside of the class. And so I might create a frame object, and then I might create a wheel object, et cetera, et cetera. And then outside the class, I might be like frame.add wheels. And then I would add the wheel object that I just created from the factory class. So I know I'll give you an example of that explicitly, maybe next week. But that's one that like is super common. Builder is also super common. Builder is when you want to you want someone just to build the house for you or the car for you. You don't want to build the car yourself. So you want the class to literally build the thing with the features that you have, versus like building the components separately and then putting them together yourself. So in a builder function, you wouldn't use the objects outside. You wouldn't be like assembling the objects outside of the class. You would literally say like, class.build or class. Set tires to 4-wheel drive, like set like, all this stuff, set engine to V4, set style to truck, set color to black, like blah, blah, blah. And then you would be like, now, class or object.build the car. And then it would like literally generate a car for you. And now you have a car object. You didn't have to assemble it yourself. And I'll show you what that actually looks like. as we move forward. But that's having the class build it for you versus having the class build components and then you assemble it outside of the class. Abstract factory. This is just like a fancy way of kind of saying, hey, I want to build the template for building a factory. So like it's kind of like in an abstract class of like a parent class of like general components, and then I can have a car factory and a house factory built off of it. Singleton is actually pretty unique. It's basically a way in programming to enforce only being able to build one object off the class at one time. There's some super fancy syntax to do that. I'm actually not 100% sure you can even do it in Python, but you can do it in C++ and Java and C# and the type specific languages. And it involves like some fancy attributes of certain functions you can do. But what you do is you kind of lock the user out from using the class. Why is that important? It's actually not good computer science, but it is used. It's important when you have like a database and the class is responsible for like writing to a database, but you do not want someone to write to the database at the same time as you. So you will create a singleton object. And as long as that object is alive, no one else is allowed to create an object off the class. And so if you have multiple pieces of code working together, if someone tries to create an object off of a singleton class that's already in use, it'll be like, can't do it. It'll just give them an error or let them know that they can't do it. Or it will just return that same object that someone else is using in memory. I know this is kind of confusing without having C++. I just wanted you to be aware. Prototype. Prototype is a fancy way of saying, I'm going to create one object, and then I'm just going to copy that object in memory. I'm not going to create more objects from the class. I'm just going to copy it in memory, and I'm going to tweak it and prototype it. So like, I'm going to I have one object that's my prototype object, and it's like, hey, I'm going to prototype this new fancy car. I'm going to prototype this new thing, and literally just going to have a fancy function or method of just like copying it in memory over and over again. So now I'm just like a Terminator replicating myself, but now tweaking little features so I can play around with it. Any questions on the basic intent of creational patterns? They're really meant to create something or affect the way that you create objects or a thing. Okay. Let's jump to behavioral patterns here real quick, and then we'll save structural for next week because those will be a little more complicated. Just to note what behavioral patterns really are. Observer is probably the most common that I see on this list right now, but it's meant to capture the way that actions happen in real life. And I want to give you a quick, crisp example in Observer. Observer is kind of like subscribing to a newspaper, right? The newspaper agency doesn't say it's over email, doesn't really care to know much about who subscribed to them, right? Or, if you subscribe to a website or something or a blog, they don't really care. All they want to do is just like send the same thing to everyone who's subscribed. So the observer, you as a user might go in there and say, I want to subscribe. Here's my email. And then the actual subscription agency basically says, okay, at a regular cadence at 12 o'clock, I'm just going to blast out my subscription news to everyone who is subscribed. And so we have an object-oriented way to do that, which is very important because in certain services and like object-oriented programming or the AGRA or whatever, you might just have like a service that's just a broadcast service of GPS. And it's just like, hey, I don't want the responsibility of knowing that you should be subscribed to me. You just subscribe to me and I will give you GPS every second, And so the other service will be like, I'm going to subscribe to the message topic or the person or the object that sends that. I'm going to give them my ID and then they're just going to blast it out to me with the rest of the people. So that's what these types of object-oriented design patterns are. That's probably most of what we got for time this week. Any questions and wrap up?
Can you send us a link to this website?
Yeah,
if you
bet.
can?
You bet. I will do that right now.
For the behavioral ones, are there cases where it can be like communicated both ways then?
I
like, does the behavior ever care who's
Yes,
receiving?
there are definitely ones that are communicate both ways, but I will say most of them are trying to abstract some communication. There's one that's on here that's not on here, which is like a proxy and like iterator chain of responsibility. Like, yeah, bottom line is yes, there's design patterns for like everything and bidirectional communication. But for the most part, like observer is explicitly, one person has the responsibility to send and the other person has the responsibility to subscribe. Um, but there are, almost infinite combinations, but a lot of the common ones are derived from like general life. Like, how do we do things today? That sounds like a good idea. Let's apply it to computer science. Then if I'm in someone else's code and I see a factory or I see an observer, immediately I'm like, oh, I know what this is, like to some degree, what's happening. Now I just need to hunt down the details. Mediators, like, I don't want these guys to know about these guys, but I do want them to be able to communicate with these guys. I have a mediator in the beginning. This is actually pretty similar to like a service-oriented architecture. Like everyone's subscribing and talking to topics, and the mediator, which is the middleware, is actually dealing with everything. This is in the context of object-oriented programming, but like it's translatable. So, alrighty. Welcome to architecture and design world. You guys are going to start to get smarter than a lot of like architecture wise, a lot of actual like just general programmers, because a lot of people don't know this stuff. So
Cool.
yeah. Ready,
Thanks
guys?
so much, Ron.
Back to you.